Hello everyone, this is Dr. Shirisha working as Associate Professor in Institute of Aeronautical Engineering College. Today we are going to discuss about one of the most prominent problems which we encounter in case of single linked list. That is how to reverse a single linked list. Let's go through that. Before going to that, let's have a brief overview on what a single linked list is, how it works, right? So let's have a look at this one. Linked list is nothing but a linear data structure which is not similar to array, where arrays are stored in contiguous memory locations, but linked lists are stored in different memory locations, but they are hooked to one another by storing the address of the next. A bit complex you might feel. Let me explain you in simple terms. Means it's like a chain. It's like a chain where every beat will store the address of the next beat, right? So there are totally three types of linked list in our hands: single, double, and circular linked lists. Have a look at their pictures. Single linked list. We run only in forward direction. We run only in forward direction. See, every node here is holding the address of its next node. If you are, say, you are at node 15, you can travel only towards 20, but you cannot go back to 10. That is a restriction in single linked list, right? So if you say there is a scenario where you have to reach the first node and currently you are at the last node. So you are at the last node and you are supposed to reach the first node. In case of single linked list, if you are working, you have to start from the scratch. But if you extend single linked list to be a circular linked list, where the last node holds the address of the first node, the job becomes quite easy. Simply, even if you are at the last node, as you are holding the address of the first node, you can simply go to the first node, right? Even this one, that is circular linked list, overcomes one of the disadvantages of single linked list. It still suffers the unidirectional issue, right? Even here, you will be running in a cyclic way, but in unidirectional way. So this disadvantage you are going to overcome with double linked list, where you have the privilege to run forward as well as backward. In both the directions you can run, right? That means each node holds the address of its next as well as previous node, right? So let me explain you what a node is. A node is nothing but a basic unit with which we work in linked list, with the help of linked list. It is a collection, or you can say that this unit is a collection of, basic node is a collection of two parts, which is a data part and a link part. And this link part is also known as pointer part because it stores the address of the next node. Got my point? So a node is having two parts. First part is the data part and the second part is the link part. In the link part, I'm going to hold the address of the next node, right? So this is the structure of a node. Coming to what head is, or in few books, it is also referred as start. It is nothing but a pointer variable which holds the address of the first node. So why we have to explicitly hold the address of the first node? When we were working with arrays, we didn't do that. We didn't store the address of the 0th element. As I said, 0th element. Index values are the crux of that. Arrays have the advantage of index values. So any value, index value, randomly you take and you can retrieve that element. Either you can insert an element in front of it, after it, delete an element or delete the element itself or update the element, any operation. So you need not run from the start 0th index to reach an ith element. If you want to work on an ith element, you need not run from 0 to I. Simply by taking the base address add it to the ith element's address, job done. But in case of linked list, as the elements are not stored in contiguous memory allocations, we do not know where the ith element is. We just have only the first node in our hands. It's a chain, right? So I don't know where the ith element is, in which location it is present. So always, whatever operation I do, whether insertion, deletion, search, reverse, whatever operation you name, for a linked list, you have to start from the first node, whose address is stored in either head or start. So I call head or start as the pointer variables which hold the address of the first node, right? So these are the 2 points which you need to keep in your mind when you work with single linked list, right? Then have to create a node and have to start working with a single linked list. So have to create a node. With the help of Python, which is having an advantage of being an object-oriented programming language, I'm going to take the leverage of classes to work with. Okay, so I have declared a class with the name node and with the constructor in it, which have 2 member variables. One is data and next. Whenever an object of this class is being created, so I'm going to pass a data to that, a value to that, which will be assigned to its member variable, whereas the next member variable's default value is none. Why none? Why? Because when I create a node, I clearly know that it is a newborn baby and it is not related to any other node. So only once it is related to any other node, its address will be placed in none, right? As it is not related, so its next part will be none. Once a node is created, it is the responsibility of the programmer to explicitly build relations. Okay, so a newborn will have the next part as none. Okay, so let's go with the second one, single linked list, whose constructor is having a single member pointer, which is pointer variable, which is start, which is used to hold the address of the first node, which is initially none. Good. Next, have to create a linked list. To reverse it, you need to create it first of all, right? So to create a list, I'm going to use the technique of appending, that is inserting an element at the last by default, at the tail, you can say inserting an element at the tail, right? So how many nodes you want? That is the basic point. N. For n number of values, I'm going to work. Initially, I'm going to read that value and I'm going to pass the data to create a node. Once a new node is created, I have 2 cases in my hands, guys. The first case is the list existing first of all? If it is existing, it's a different story. What if it is not existing? That means the node which you have created just now becomes the first node of your list. Then have to figure out that the list is existing or not, simply by checking whether the start is holding none or not. If its content is none, then you can simply understand that the list is empty and new node is the first node. So store the address of new node in start. Okay, the second case, a case where I have handful of elements. If I have handful of elements, then simply I am going to store the address of the first node in temporary, and I'll take the hops unless I reach the last node. What is the beauty of the last node? Its next part, that is the address part or the link part, will be none, which specifies that it is the last node. There is no node after it, right? So I'm going to go with this while loop and this condition, and I'm going to take the hops unless my temporary node's address part, that is the link part, is none. Once I reach the last node, I am going to build a relation between the temporary and the new node by storing the address of new node in temporary's next. Okay. So this is a small function in Python to create, which I'm going to explain you using animation. The case one, a case where my start is filled with none. There is no element in it. So as soon as I create a node, its address I have stored in start, saying that start with a new node as the first node, right? So what if it is having handful of elements? Say two elements are there. I have to uh, append the element, the new node as the last. So I have named the first node as temporary. As its next part is not none, I'm going to take a hop. So when I took a hop, I reached the next node where its next part is none. So I have stored the address of the new node in it. Thereby I have built a relation. You can see I have built a relation between temporary and new. This is how I'm going to append. I'm going to perform the append operation. Then our main point, how to reverse a linked list. It's quite easy, guys. This is the list which they have given. So if I write it 21, 22 and 23, now I want that to be displayed as 23, 22 and 21. Right, this is the task. So for this purpose, the game will not run just with a temporary variable. Even I need another variable to store the temporary address, which I'm going to use it as previous, PREB. Initially, I have stored none in it and I have named the first node as temporary. Right? So why the temporary? That means I'm trying to reach the last node. If it is not none, right? If it is not the null node, I'm going to name the temporary's next node as next. Have a look. Temporary's next part is 3000, and to the node which is at location 3000, I have named it as next. I have named it as next. Next. So I'm going to store the content which is present in previous in temporaries next. What is the content present in previous, which is none? I'm going to store it in temporaries next. That is 3000 will be overwritten by none. You can see that the list is now broken into two pieces where you didn't lose, even though you have broken the chain, you didn't lose the content, because next is the node or node which holds the remaining part of the list. Whatever the list it may be, it is holding it. Right. Next step. So make the content, the address in temporary as the previous. So now previous is holding 2000, which is that means the none, the content none, which was previously on previous pointer, is will be overwritten by 2000. Once it is overwritten, now make the temporary take a hop or take a position of next. So next is pointing to the node at location 3000. Now it is represented or named with temporary. Have a look. So now previous is holding 2000 and temporary is the name given to the next node. These are the changes which we have done. Now we have two lists in your hands, right? So let's start. Again, if temporary is not none, yes, obviously it's not none, it is 3000. So the name the next node of your temporary with the name next. So the next node of temporary is at location 4000, name it as next, right? So now now changing the addresses, whatever the content, that is a temporary node pointing to, saying that this is my next node, make it as the previous one. So now temporary is pointing to the element which is at location 2000, which is at location 2000. Right. So next, now again override the content of previous with the content of temporary. Previously it was holding 2000, now it will be holding 3000. Right. So once it is holding like this, now temporary is going to get the name of the next, right? Have a look at this one. Now previous is 3000 and the next will be getting a new name as temporary, right? This you have to recursively do until unless you reach a case where temporary is none. Even here temporary is not none, guys. It is 4000. Repeatedly you have to do this, right? Let me explain you the same with the help of Python, right? Let's move to Python, guys. Yes, guys, we are in the Python environment. Let me open a script to write the same. Yes, this is my file where I'm going to write the code for reversing a single linked list, right? Let me write the same in a comment line, because if a novice opens the script must be able to understand what this code is meant for. Reverse a single linked list, right? To reverse a single linked list, right? Very good. Reverse a single linked list. Now, I always start my working with a driver code, guys. Driver code gives me a flexibility. What type of input I'm going to read, to which function I'm supposed to pass, then what are the parameters I'm supposed to pass, what are the functions I'm going to need. Once I can get the blueprint of that, then I can start writing the definitions of the functions. So first I want to look at my driver code, how it looks like. Let me do the same. Driver code, right? As I'm going to use classes, and let me name the class also with a relevant word, because I'm trying to reverse the linked list, a single linked list, specifically speaking, right? Let me create an object for the same, RSLL, and the name of that class be reverse SL. Okay, the name of the class is reverse SLL, and the object which I have created is RSLL. As this specific Python is case sensitive. Okay, okay. Let me create the list first of all before reversing it. Right? Let me do that. RS create. Create is the function which I need to write. I'll keep this in mind. Okay, I need to create that first. Next, I just want to see how it looks like. So, this is the given linked list. So display function I need, right? RSLL dot display to look at my list, how it looks like. Now I'll reverse it, right? So to reverse it, I need to write a function explicitly. RSLL dot reverse. Reverse is the function which I'm going to call with the help of my object. Once I reverse it, I'd like to see how it looks, right? Print reverse a linked list. Reverse a linked list. Okay, so for that I would like to call the display function of the same, right? So what? I need a class reverse SLL. Using that, I'm going to create an object RSLL. With the help of the object I created, I displayed, I reversed, then I again displayed to check how my list got reversed. Very good. This is the blueprint. If I need, I'm going to modify it in the future. So before going for the reverse class, first of all, I need to write the class to create a node, right? Class node. Okay, let me write the constructor for the same. Self data, right? So self dot data and these are the two variables that will be in my hands. One is data and the next is the next part, right? Which will be initially none, because this new node is not holding anyone, is not related to anyone, right? So I have created a node with its two member variables. One is data and the other is next. Now I'll go with my class, which is reverse SSL, REVERSE. This is the name which I have given to my class, reverse SSL. Okay, so the constructor of this one, this class will have only start, that is the pointer with variable which holds the address of the first node. Self dot start is equal to none initially. Why? Because initially there is no list, so I have to make it as none only. Now I'll create a list to modify the things. Create. So to create, first of all, I need to know how many nodes my list will have, right? So let me read the same. N is equal to int of input. Enter the number of nodes. So for all these nodes, I have to run my code, right? Append basically. For I in range of n. For n elements, I'm going to run this code. Okay, so for n elements, I need to read the data. Data before creating a node, I have to read the data to pass it to its constructor, right? So int of input, enter the data. Right, enter the data. Now I'm going to create an object. New node of what class? Node class. Node class to create a node, and I'm going to pass data as a parameter to that. Right? So while creating, as I said, I need to take a caution where the list is not existing and the new node which I have created just now is the first node. And the second case where I have handful of elements, I just need to append, right? So to work with the same, if I'm going to work with my start variable, pointer variable, which is not supposed to be none if there are handful of elements. It will be none if there are no elements in the linked list. If this is true, then I'll make my new node as the first node. Okay, as the first node. Else, I'll name the first node as temporary, and I'll take the hops till I reach the last node. Once I reach the last node, I'll build a relation between the temporary and the new node. Okay, so I don't know how many nodes are there. While creating, I know that there are n number of maximum, but I don't know, clearly I don't know how many numbers, which ith number I am, right? So I'm going to use while temp next not equal to none, right? While temp next is not equal to none, I'm going to take the hops. Temp is equal to temp next. So this loop will break when I reach the last node. Once I reach the last node, I'll store the address of the new node in temp next, right? So this is how I have appended. So if there are n elements in my list, for the first element, the if will work out because it is going to say that the start is none. For all the remaining n minus 1 elements, else part is going to work out and it is going to append the new node into the existing list. Okay, so I have created. Very good. Now I want to reverse. This is the crucial part, guys. This is the function for which we have worked till now. So reverse it. Reverse is the function name which I have given, and yes, reverse. Let's write it. To reverse, as I said, I need two pointer variables. Previous, which will be filled with none initially, then temporary will be the name given to the first node, right? So once I name these to fill these two temporary pointers with the data, I'll start. While temp is not none, that it is until unless I reach a node where temp is not none, that is until unless the final node. Next is the name given to the temporary next. Temporary next is the name will get the value of the previous. Previous will get the value of temp. Temp will get the value of next. Very simple, guys. So have a look. Next will get the value of from temporary next. Temporary next will get the value from previous. Previous will get the value from temporary, and temporary will get the value from next. It's a cyclic way. Have a look at this one. We started with next. We started initializing to the next, and we ended assigning the value of next to some other variable, which is temp, right? So once this loop is done, I'll make the self start change its first node's address with the previous. Okay, so this is my reverse function. Okay, so I have created with the help of class node, I have written a constructor to create a node. Then I went to reverse class where I have created a linked list. I have written a function to reverse it also. What about display? Right? Display is the function which is going to show me how my list looks like. Initially, when I created, how it looks like, and after reversing, how it looks like. Okay, so temp is equal to self start. Guys, even you here also you can cover the case where if start is none, then the list is empty, and you can return. Okay, let me do that. If self start is none, that means this is a case where the list does not exist. Then print list is empty and return. You can do that at any point of time. You can do that, my dears. Okay, if this is not the case, it is existing, then name the first node as the temporary. Then while temporary next is not equal to none. Okay, while the temporary next is not equal to none, I'd like to print the temporary data. I'll print temporary data, and I'll want to see an arrow mark connecting them. So I have used end. So I have used end to see that each and every element is connected, a one-way connection, because you know that single linked list is unidirectional. You can run only in forward direction. Okay, once I print, I'll take a hop. Temp is equal to temp next, right? Once I reach the last node, while loop will break. Once I reach the last node, then I will print the data present in the last node. You can see that I have taken an explicit case where I'm going to print the data in the last node, so that after the last node, I don't get this arrow mark. Okay, so let me go through this driver code and compare. I have to create a class. I have created, and I have written the constructor for the same. Then I created a single linked list, then displayed it. I have written the function for that also. I've reversed it and displayed it. Yes, I think I have finished my job. So yes, this is my reverse function. Reverse SLL is the name which I'm going to give for it. Appropriate name, right? Always give relevant names, guys. Okay, let me compile this one first. So how many nodes you want? Say 5. 1, 2, 3, 4, and 5. So the initial list is as I have appended to create. So after 1, I'm going to get 2. After 2, 3. After 3, 4. After 4, 5. And the reversal linked list. So you can see 5, 4, 3, 2, 1 is the reversal linked list. Yes, guys, job done. We have a reversed the linked list. Have a look at the main crucial function, which is the function reverse, right? Have a look at this one. Okay, so I have taken the help of 2 pointer variables to reverse a single linked list. So with this, I'd like to conclude. We have seen what a linked list is, right? What are the basic limitations of that, and how a single linked list looks like, and what are the variants of a linked list, first of all, and what a node is, how to create a linked list, and we have seen the animation how to reverse a linked list. And with the help of Python code, we developed a script to reverse a single linked list. So, guys, even we have done videos on how to search an element in a linked list and load more functions on single lists, like inserting an element, deleting an element in a single linked list, where insertion and deletion have 3 cases: inserting at the end, or inserting at a given position. The same with the deletion. We have covered videos on all the different cases. Please go through our videos and do follow. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.